The OSI Model by
Andrew Brown,
Christian Rogan,
Cody Leitzel,
Joe Myers,
Nick Houlihan.
A handy acronym to help remember the layers of the OSI model is all people seem to need data processing. And A stands for application, P for presentation, S for session, T for transport, N for network, D for data link, and P for physical.
Application layer. The application layer serves as the window for users and application processes to access the network services. This layer contains a variety of commonly needed functions: resource sharing and device redirection, remote file access, remote printer access, inter-process communication, network management, directory services, electronic messaging such as mail, network virtual terminals.
Presentation layer. The presentation layer formats the data to be presented to the application layer. It can be viewed as the translator for the network. This layer may translate data from a format used by the application layer into a common format at the sending station, then translate the common format to a format known to the application layer at the receiving station. Data compression reduces the number of bits that need to be transmitted on the network. Data encryption. Encrypt data for security purposes.
session layer. The session layer allows session establishment between processes running on different stations. It provides session support, performs the functions that allow these processes to communicate over the network, performing security, name recognition, logging, and so on.
The transport layer. The transport layer ensures that messages are delivered error-free, in sequence, and with no losses or duplications. It relieves the higher layer protocols from any concern with the transfer of data between them and their peers. The transport layer provides message segmentation. Message segmentation accepts a message from the session layer above it, splits the message into smaller units if not already small enough, and passes the smaller units down to the network layer. The transport layer at the destination station reassembles the message.
Network layer. The network layer controls the operation of the subnet, deciding which physical path the data should take based on network conditions, priority of service, and other factors. It provides routing, routes frames among networks, subnet, traffic control, routers, network layer intermediate systems, can instruct the sending station to throttle back its frame transmission when the router's buffer fills up. Frame fragmentation, if it determines that a downstream router's maximum transmission unit MTU size is less than the frame size. A router can fragment a frame for transmission and reassembly at the destination station. Logical physical address mapping translates logical addresses or names into physical addresses.
Data link layer. The data link layer provides error-free transfer of data frames from one node to another over the physical layer, allowing layers above it to assume virtually error-free transmission over the link. To do this, the data link layer provides link establishment and termination, establishes and terminates the logical link between two nodes, frame traffic control, tells the transmitting node to back off when no frame buffers are available, frame sequencing, the transmits receives frames sequentially, frame acknowledgement, provides expects frame acknowledgements, detects and recovers from errors that occur in the physical layer by retransmitting non-acknowledged frames and handling duplicate frame receipts. Frame delimiting creates and recognizes frame boundaries. Frame error checking checks received frames for integrity. Media access management determines when the node has the right to use the physical medium.
Physical layer. The physical layer, the lowest layer of the OSI model, is concerned with the transmission and reception of the unstructured raw bit stream over a physical medium. It describes the electrical, optical, mechanical, and functional interfaces to the physical medium and carries the signals for all of the higher layers. It provides data encoding, modifies the simple digital signal patterns, ones and zeros, used by the PC to better accommodate the characteristics of the physical medium, and to aid in bit and frame synchronization.
This has been the OSI model. Thanks for watching.